Today we're going to be listening to Ram's presentation about climate, which is going to be 20 minutes, as he just said. Ram is a professor of climate at the University of California in San Diego, and in 1976, he discovered that CFCs, or chlorofluorocarbons, are a greenhouse gas that adds to the global warming. In 2015 in Paris, he was Pope Francis' climate advisor, and he also started the university course Bending the Curve. And today he's going to be holding his presentation for us that we're going to listen to. So you can start your presentation, Ram, and share your screen.
Thank you. I'm really delighted to join you all.
Yes. Oh, sorry, I forgot to add, if you have any questions, you can write it into the chat as well. And we will take all these questions after the presentation. And if you're not speaking, you're allowed to mute your microphone so you don't disturb the presentation for everyone else.
Sophia, can you see my screen now?
I can, very clearly.
Very nice. Let me see. In my screen, I still see the, yeah, perfect. Good evening to everyone. Of course, I'm going to talk to you about climate change. In the 20 minutes, I have three topics I want to cover. The first one is, how do we know what we know? We here meaning scientists. And the second is, why should we care about climate change? And the third is, what are the solutions we should be exploring? I'm starting off with a picture of the photograph of the sun around 6:30. This is about 20 minutes before sunset. I took it from my backyard. It is just, the sun is just over the Pacific Ocean. And 2 days before this, was a major fire. As you know, California, we are suffering from fires. Our fire extent increased by 400% in the last 30, 40 years. What happens is that after the fire, soot particles and other particles from the fire takes off the blue on the green. And it's just an incredible picture. It looks the sun is angry at us. Normally it's supposed to be yellow. I don't know how it comes across the screen. This was a reddish, red hot sun. So that is what is happening in California. We are seeing climate change almost every day. I think as Sophia mentioned, I got into this field in 1970. The first 5 years I was studying the climate of Mars and Venus. And then I switched over to studying Earth's climate. And I thought I'll share with you what I have learned from 50 years of observing our planet. Okay. The first thing is, this took me 30 years to figure it out. Everything we see around us in terms of climate is in a delicate balance. And it is just amazing that this delicate balance is there to protect our well-being on this planet. So to speak, our planet is indeed in a Goldilocks zone. Remember, the Goldilocks is the little girl who likes her porridge and everything at just the right temperature. And this phrase is used by astronomers, Goldilocks. And the second thing I've learned is that everything is connected, and any change, however small, in any corner of the earth is felt by the entire ecosystem and by all plants and animals, including humans. In this sense, the climate system is like COVID, right? Infection anywhere in the planet is disease everywhere. Same thing, emission anywhere in the planet is climate change everywhere. It is this interconnectedness which makes climate change an existential threat. And I'm going to talk to you about how I came to that conclusion that climate change, if it's unchecked, does pose an existential threat. So let me walk you through this Goldilocks zone. We see our 4 planets. Inner planets, the Mercury on your left-hand side, then Venus, Earth, and Mars. You see how Venus is super hot and Mars is super cold. And Earth is in the right temperature. Astronomers say that it's in the right temperature because it's at the right distance from the planet. But you see, after I finished my graduate studies, I worked with NASA and designed a climate satellite. And from there, I measured how much sunlight is being reflected and all the key things about the planet. What I found was what made me realization about this Goldilocks zone. Of course, we are at the right distance, but that's not the only thing. For example, without the clouds, you see, my data show the planet would be 20 degrees too hot. Okay, there won't be ice or snow anywhere. I know many of you skied from your home to Stockholm University. With 20 degrees too hot, you have to walk, not ski. Another interesting, give me a list. If the clouds of the planet had just been about 3 kilometers higher in the atmosphere, the planet would have been 35 degrees Celsius. And 35 degrees Celsius is when no one of us can tolerate. That's the ultimate of deadly heat. Likewise, I'll give you another statistics. The planet reflects 29% of the sunlight back to space. That 29% is because it has the right distribution of the land and the ocean, because land reflects twice as much as the ocean. It has the right distribution of ice. Ice reflects 80% of the sunlight. So if you didn't have this perfect combination of land, ocean, forests, and snow, say if the albedo had been instead of 29, 26%, the planet would be too hot by 8 degrees. We have never seen a planet warmer than 5 degrees in the last, 80, 100 million years. Likewise, if on the other hand, the albedo was just 32% instead of 29, we would be in a complete ice age in every part. So that's how delicately balanced everything is, to make this at the right temperature so that water can exist in all 3 phases: ice, liquid in the ocean, and vapor in the air. So this is about 5 years after I got into studying Earth's climate, it became clear to me this CO2 warming could be a huge problem. But I thought of it as just as a hypothesis. So we scientists, how do we test hypotheses? We make predictions. So I teamed up with a meteorologist. We made statistical dynamical prediction that if the carbon dioxide keeps increasing with business as usual, the warming due to CO2 should be detectable by year 2000. In other words, we said, if you don't detect the warming by year 2000, then the theory is wrong. And I think it was the first such prediction made. It was published in Science magazine. It's an American journal. And it was in 2001 when the IPCC, which is a United Nations group of scientists, over 1,000 of them, concluded there is a discernible warming due to human activities. Okay, I'll soon, in a couple of slides, talk about how a prediction made by a famous Swedish scientist also was proved. So let me just give you a very, very quick background of what is this carbon dioxide problem? Okay, as you know, fossil fuels are hydrocarbons, right? Chains of hydrogen and carbon atoms attached together. And when you burn it, put it in your fuel tank and burn it, meaning, light a spark. So the hydrocarbon splits, releases the energy, but the carbon combines with the oxygen to form this gas, carbon dioxide. Once you release that CO2 into the air, about 50% stays for a century or more. And about 20% stays for thousands of years. So I have no hesitation in predicting the carbon dioxide, which is released by James Watt's first steam engine more than 150 years ago, is still here. Half of it is just we are breathing it. So how much have we emitted? 2 followed by 12 zeroth tons, 2 trillion tons of CO2 we have emitted, okay? And how much of it is still in the air? 1 trillion of that CO2 is still in the air. So it's covering the planet like a blanket. And look at the thin atmosphere shell. And we have dumped 1 trillion tons into that thin layer. So it covers the planet like a blanket. Just like a blanket keeps you warm on a cold winter night. I don't have to mention about cold winter night to Swedes. Why does it keep you warm? It's not that the blanket is giving any heat to you. It just traps your body heat. That's exactly how carbon dioxide warms the planet. It traps the infrared heat. We call it infrared radiation, infrared heat given off by the Earth's surface. And so warms the blanket, and then the blanket warms you back, surface back, okay? And many scientists, I would say at least 2/3 still think of it as a carbon dioxide problem. And my own work has been, in addition to CO2, 4 super pollutants, methane, which is about 100 times more potent on a 20-year time scale, black carbon, which is 1,000 to 2,000 times more potent than CO2. Black carbon is the same as the black smoke which comes out of diesel truck. And then hydrofluorocarbons used as refrigerants, as CFCs, and ozone. We have determined, so how do you go from this blanket thickening to the heat trap? That involves you have to bring in quantum mechanics. This was one of my early tools I had, understanding the quantum mechanics of molecules. So once you know that, once you know the concentration, then you can estimate the heat trap within about 5-10%. So I have estimated we have trapped 900 trillion watts of heat. That's huge. How do you relate to that? Think about all the heat we have released from fossil fuel combustion. Okay, that's only 16 trillion watts. So the energy we have trapped is about 50 times more than the energy we released using fossil fuel. I can give you other statistics, but anyway, it's a huge amount of heat we have trapped. To the extent that the CO2 is going to be there centuries to thousands of years, that heat is there, okay? So now, I was not really happy with this blanket concept or greenhouse effect. I wanted to prove it to my satisfaction. So I show you the satellite, which I helped NASA design. Inside is an instrument, it's a telescope, and we had an infrared radiometer. We scanned the Earth to find out how much heat was escaping from the atmosphere. We call it clear skies. So in that unit of watts per square meter, we determined about 268 was escaping to space. Then we took all the temperatures and estimated how much heat was coming from the Earth infrared. That was 400. So we estimated the blanket thickness directly, okay? That blanket is the natural blanket, mainly, water vapor and carbon dioxide, okay? And now comes the second thing. If all that was happening, okay, so now we have a proof that the atmosphere traps infrared heat, okay, acts like a blanket, and we are thickening the blanket. And now comes the second prediction, which I was interested in testing, which is that the famous Swedish chemist, Nobel laureate Svante Arrhenius in 1896 said, when you put CO2, you trap heat, the air gets warmer, that air would hold more moisture, water vapor, and the blanket will become further thicker. It's called water vapor feedback. I don't know how many of you realize without that water vapor feedback, none of us would be talking about climate change problem. It will be about half as important as it is now. So that is the key. I spent 15 years verifying that. And indeed, Mother Nature behaved exactly as Svante Arrhenius predicted. I found as the planet heated up between winter and summer, or the whole planet, as the climate warms, the blanket becomes thicker, almost within 10-15% of what Arrhenius predicted. So that is how we know what we know. We make predictions, then we see the system, and we confirm those predictions. Of course, not all our predictions came true, okay? So now, why do we care? Why is this such a big deal? And that was the major development happened in 2017. Many meteorologists in 2017 wrote a joint journal issue with 22 studies and concluded that many of the intense weather events happening would not happen without the warming. See, the planet has warmed by about 1/8 of a degree since 1980. And they said that is what triggered all this weather. And I'm sitting in California. We have become a poster child next to the Arctic where you all are because of the fires. So why does the warming create fires? See, there is an equation which I put there. It's called Clausius-Clapeyron equation. It shows how the vapor pressure increases with temperatures. That's the equation Svante Arrhenius used. Believe it or not, that one equation holds a death grip between warming and all the weather extremes, droughts, fires, hurricanes, storms, floods. I don't have time to go through that. But here what it shows is that first, when you increase the temperature of a surface like a tree or a plant or a soil, the evaporation increases exponentially with temperature. So that is the issue. Things are drying out, so they become a fuel for fires. And many scientists have published papers sort of confirming this, okay? So when we say that climate change is going to cause these storms, hurricanes, it's not speculation. It's not based on models primarily, but there is a theoretical underpinning, an equation like that holding a death grip on all this, okay? So what happens then? Linking global warming to weather extremes has made the problem more immediate and more threatening, but at the same time provide new opportunities to persuade people we need to take action. For example, during the time the planet warmed from 1980 to 2019, about 1/8 of a degree, the number of disasters almost doubled. I don't know how many of you know, amongst all the natural disasters, earthquakes, landslides, glacier disruption, weather events, or 85% of natural disasters are from weather events, droughts, floods, storms, fires. They doubled, and the total people affected increased by 1 billion people. This is over a 20-year period. And the cost of it is close to $1.3 trillion has been spent. And people normally forget when they put the deaths, but the fossil fuel air pollution over the 20-year period has killed 140 million deaths. So of course, fossil fuel has made our life enormously, pleasurable. That we can, I can fly, come to Sweden, do so many things, which has come at a huge cost. So what we need to say is that fossil fuel was great, but it has become outdated. We are paying too much of a price for it. Okay, and this weather disasters enable us to take this problem to the public. So now let me go to the solutions. Just like I predicted in 1980, 3 years ago, we published the study, and we found the 1.5-degree warming, which United Nations was saying will happen in 2040, is because they made a linear extrapolation. So when we did a proper statistical projection of that, we concluded that 1.5-degree warming is going to happen in 10 years. So that's an impending major threshold. By the time you cross 1.5 degrees, you have gone to a climate we have not seen in the last 150,000 years. Okay, and I expect that climate change will move into our living rooms just like COVID. It's a disaster, but I also unfortunately see as an opportunity. Everyone would feel it. And there will be an immense pressure to take actions, just like there's pressure for vaccines. So in the sense, I am glad this warming is going to happen quicker, so we would solve the problem before we keep putting more and more pollutants. Okay? So keep that time in mind. So the problem is not 30 years, 100 years. The problem is 10 years from now. This is one projection. If we ignore this by 2030, keep going. This is the droughts over the planet beyond 2050, and all the red areas are in mega droughts, the entire Amazon and the entire Mediterranean and all of southern California, etc. So our Goldilocks zone is going to shrink quite a bit, while the population is going to reach 8, 9, 10 billion. I'm not sure where we're going to produce the food and water, etc. Okay? So I organized a meeting at the Vatican 3 years ago, and we had top ecologists, economists, several Nobel laureates, and we concluded that because of the connection between climate change and extremes in weather and extremes in climate, it poses an existential threat to Homo sapiens. Okay? So we are no more talking about species, polar bears, we are talking about us. Okay? So, but still, fortunately, it's not too late. And plenty of scalable solutions are available. We can talk about this. And we have a decade to implement. And the one thing I have learned looking at that is that we can't kid ourselves saying, oh, it's going to be easy, it's going to be cheaper, etc. No, we need to make enormous investments and we need to accelerate the implementation, okay? One thing I would not want any of us to forget is that climate change poses intergenerational equity issue. This is what the Friday for Future, thanks to Greta Thunberg and others, have really highlighted, that we are destroying the future for the young population and generations who are yet to be born. But I want to talk about another equity issue, intragenerational. This is a study I had done. I presented this, published this, that more than 50% of the emission comes from the wealthiest 1 billion. The poorest 3 billion, their contribution to the climate change problem is about 5% or less. They lack access even to basic fossil fuels. You see, that the picture I have is my grandmother's kitchen. And that lady is, I took this picture just about 5 years ago. So there are 3 billion are still cooking the same way. And we know when it becomes an existential threat, who's going to go down that cliff first? It'll be the poorest 3 billion, who had almost nothing to do with this problem. So we can't forget that, okay? And we are not only causing destruction of ourselves, we are causing destruction to billions who are, innocent billions. So these are the solutions. How do we bend the warming curve? I think, everyone is focusing on bringing down carbon emissions. We have to, but it's a slow thing. Nothing is going to happen. Even if you bring carbon emissions to zero in the next 20 years, that the impact on the next 25-year warming is only 1/10 of a degree. So it's not going to bend the curve. So we need to cut down the super pollutants, methane, black carbon, ozone, and HFCs, which will bring down the warming immediately. So the immediate bending. And of course, we have to switch from fossil fuels to renewable. That's the carbon neutral. That's what is going to give us long-term sustained bending the curve. I think there is a low-hanging fruit. If we can eliminate food waste, I don't know if how many of you know, 40% of the produced food is thrown into the garbage in the West. In the South, about a third of the food is destroyed at the production by poor storage, etc. But my own feeling is none of that is going to happen. For the first three to happen, we need basic societal transformation. We need campaign for climate action. This is what the Friday for Future is doing fantastically. But I think we have to educate the public, climate education, so that everyone knows about the urgency. I personally think we have waited too long for top-down actions. Now that action has to come from bottom up. People have to demand. And I find most are still unaware that they are sitting just next to that cliff, okay? Of course, individually, we have to change behavior. We have to motivate others. I'm going to just give you a perspective of what we are talking about. And if you go back 20,000 years ago, we were in an ice age. We recovered from that ice age 10,000 years ago, drifted into the Holocene, relatively stable climate, which is what permitted agricultural revolution, which led to industrial revolution. Now, we are in an unstable climb on the temperature. Like I said, in 10 years from now, we're going to pass the climate we witnessed 130,000 years ago. Another 30 years, we would have passed a climate which we have not seen in the last 30 million years. So when you go back to the interconnectedness of the problem, humans, the poorest 3 billion, all the ecosystems, all the species, I don't know if they can survive such a rapid change because they've never seen this. So biologically, we don't know how to adapt to this, okay? So that's where I would like to leave, but I don't want us to forget this is still a solvable problem. I'm going to just leave it there. I'm not going to talk about this. I always conclude with, if I talk to the young people, what is it they can do? And you can look at that. So let me just conclude with, I'm going to stop sharing my screen. Thank you so much for patiently listening.
Thank you, Ram. That was really good. I really enjoyed listening to that. It was really easy to understand, or I found it was really easy to understand. But now if people have questions, you're welcome to write it in the chat, and I will read them up for Ram to answer. I see one question from Martin Hedberg, where he has said, I am a bit skeptic of the narrative of solving the climate. One, because complex adaptive systems do not have solutions, and two, the narratives are missing destruction of ecosystems. Do you want to say anything about that, Martin, when you
Yeah,
listen to, or Ram?
I think that is brilliant and fantastic. So let me qualify what I meant by solving the climate change problem. There I meant the technical solution. Okay. So all we have to do is switch from fossil fuels to renewables. So we have stopped emitting CO2. Okay. And the second thing we do is extract the carbon. And remember, I said there is 1 trillion tons of carbon up there. So we found if we can take 2/3 of it, that's about 660 billion tons. All right. And for you to know the magnitude of that, the entire solid waste, the junk we throw in garbage every year, the entire summer, it's 2 billion tons. This is 660 billion tons. Okay. So I had meant to say, I think from now on, I will clarify that, is that theoretically, it's a solvable problem. And the question is, if I suck the CO2 out of the air and stop putting more CO2, the climate has already warmed a degree, and you are living in the region which has warmed the hottest. Arctic has warmed by 3 degrees. So the question is, would the system go back from the Anthropocene to the Holocene? Okay. And I've looked at that issue and I found the Arctic about 50 years ago warmed by 2 degrees and then back. So that gives me a little bit hope. We are still within the reversible part of the system. So in that sense, I had meant what, so in other words, yeah, that's the clarification I want.
Let me just clarify a bit. I'm a meteorologist, by the way, and I agree totally. Of course, that's sort of the technical part, that we need to leave the carbon in the ground and take away carbon from the atmosphere and the oceans and bring it back to some sort of solid form. But at the same time, sort of the narrative that we are in control of the system, and the narrative that do you think that would sort of be sufficient, actually? I mean, the loss of biodiversity and look at the planetary boundaries, for instance, and we would sort of mess up the system in another way as well if we focus too much on carbon. I mean, that is one of the things that we need to sort of take care of course, but there are so many other issues as well. And isn't it on a higher level when you study, for instance, what Donella Meadows said, and on her sort of on the lever to look at the goal of the system, or the paradigm of the system, and not only on the parameter level?
Martin, yeah. Look, when I see 3 huge problems here. One is the climate part. The second is the biodiversity and species extinction. And the third is the population. Okay. And all of these 3 problems deal with the tragedy of the commons, right? The population problem, I want to have children, right? So we're not looking at the commons, how we are damaging. So as far as the tragedy of the commons hangs over your head, none of these problems are solvable, except the climate change issue. And let me pose a most radical thought. The population can increase. I'm not claiming, don't get me wrong. I'm just giving you a thought experiment. Let the population explode, but if everybody uses renewable, right? At least the climate system will still be impacted by changing the species, because the species biology of the planet controls the gaseous concentration. There may be other issues. So at least this is a solvable problem in that sense. It has a technical solution. I don't see there is a technical solution for the population problem. And I don't see there is a technical solution for the species extinction, because as the population is increasing, we're going to displace the species. Those are coupled. A climate change in problem in that sense is not so coupled with the other two unsolvable problems. Okay, so so that's what I had meant. But given that, I hesitate to be too negative, because there are young people in this audience. I don't think we are going to cut down our emissions and extract the CO2. They're all expensive. With the way the political situation is unraveling, every country wants to become nationalistic. This requires global solutions. I'm very doubtful if we as planet are going to come together. So in that sense, my technical solution also depends on the global cooperation, okay? And I'm getting very pessimistic if we can people to come around. And I see the United Nations process become very ineffective. The Paris summit, which I was part of as Pope Francis science advisor, so I had a front row seat. I was shocked that everybody just signed a piece of paper without any commitment, and we thought it was the biggest victory. So that's what we have reduced to.
Thank you.
Okay, and next on my list for asking a question, we have me. So if you want to say your question, you can unmute yourself and ask it.
Yeah, I was wondering what your connection is to ecocide, making it a crime, both because it would, I think, help stabilize the climate and protect biodiversity. And a number of countries are now beginning to look interested in it, so it looks more doable than it used to be. And so what's your take on making ecocide an international crime? And if so, how could we get support for it?
I have not thought much about the biodiversity issue. So I don't know if I can comment on that. I have some kind of a rough answer I can give, but I've not understood the nuances of the complexity of the biodiversity part to know if an ecocide type concept would work. Is in the climate change, what they're exploring is an indirect way of doing that by carbon pricing. Okay, pricing the carbon that every polluter pays. I'm not convinced that's working either. So maybe an ecologist here can answer that. Somebody here would want to venture.
I think from the carbon point of view, large-scale destruction of nature, which is what we're trying to make an international crime, would harm carbon sinks and release further carbon into the atmosphere. That's actually the take I should have asked you about.
Yes, but the thing is, how do you enforce it? You go back to the tragedy of the commons, for example. We export food, we meaning Americans, we export food from Amazon, right? And to produce our food, if the locals, indigenous population is destroying their forests, who pays for it? And I think the same issue holds with China, because of course China has become the major carbon emitter. But 2/3 of that is to export to the rest of the planet. So are we guilty by buying the Chinese product? Or are they the guilty party by using wrong technology to manufacture our goods? So I see all of this as a governance issue. And I don't see anyone governing anywhere in the planet. As we know, in America, in the last 4 years, we decided we don't need the rest of the world. We can survive by ourselves. So it has become incredibly complex politically. And as a physical scientist, I'm trying to narrow down to technical solutions. So I want to assert that the climate change has technical solutions. When you go to
I shouldn't have asked you without having it in a framework where I can't explain what it would do and what it intends to do and how it would be enforced. So please remove it from the agenda for now, and let's see whether at some other point I could ask you and give you the background so that you understand the point of it and how it would work.
Okay, shall we move on to the next question? Is by Svetlana. You asked, you wrote a question in the chat a while ago. Do you want me to read it, or do you want to ask it yourself?
Do you want to ask it? Yeah, it's actually from my partner Eric Peel, so he can try to ask the question himself.
Yeah, I read your question.
Okay.
Okay.
Go ahead.
I think the question here is just that we have all these species of coolants that have been, that have been emitted together with the carbon dioxide, and this is hiding some of the warming effects. So when we get to this point where we start reducing carbon emissions, we'll start seeing that additional warming coming up. So the question is, to what degree can we then offset that warming by quickly reducing the other short-lived greenhouse gases? And a follow-up question to that is, if we start this process by reducing the short-lived greenhouse gases, and thereby reducing the signal, so we're not seeing the real heating, isn't that difficult from a policy perspective, to convince people to reduce the carbon dioxide?
That's a fantastic question. I mean, that is the question which has been completely ignored by IPCC, and it's being ignored completely by all the people pushing for carbon neutrality by itself. So the issue here is the following. So let me take 30 seconds to explain it, and then I'll answer that question, which is that when you burn fossil fuel in your car, you put CO2, but you also put other pollutants which cause air pollution. But that air pollution is particulates, and they act like mirrors and reflect sunlight back to space. So roughly 40 to 50% of the warming effect of the CO2 has been masked. I think of it as a mask by this reflection. So think of it as mirrors on the blanket, okay? So while the blanket traps your body heat, these mirrors have reflected the sunlight. So now the question is, if tomorrow we made a hard push to bring down carbon emissions to zero, let's say we do it in 10 years, because the mirrors will be gone, but that blanket is still there of all the carbon emissions you did the last 150 years. So I'm personally thinking the planet would really heat up by about 0.5 degree. And imagine the global fiasco, particularly in America, where the science is still being criticized. Oh, see, we told you, we shouldn't listen to these guys. They made us cut the CO2 emissions, but the planet is heating up. So that is why I came up with this idea that cut the super pollutants at the same time, because the super pollutants' lifetime is only 5 to 10 years. The black carbon is only 2 weeks, okay? So imagine this. So when you cut the CO2 emissions, you are not going to reduce the thickness of the blanket. You are just going to prevent the blanket from getting thicker. So you're still stuck with this 1 trillion ton blanket. And when you cut the CO2 emissions, the mirrors are gone. So finally you see the full beast. But if you cut the superpollutants, their lifetime is only few, the blanket will start thinning. So it's a complex issue. So that is why if you saw my solutions, I said, cut the superpollutants or short-lived pollutants to thin the blanket while you are cutting down your CO2 emissions. So we need to do, and then we have to suck some of the carbon out. See, the carbon dioxide blanket, you cannot thin it by just cutting down the emissions. The only way to thin the carbon dioxide blanket is just to suck that CO2, mechanical means or natural means, out of the air.
Cool. We'll go on to the next question, and it's from Anne-Lise. Do you want to say it yourself, or do you want me to read it up from the chat?
I'm muted. Well, you can read it, that's fine.
Okay. Annelise wrote, you coined the concept of bending the curve. When was that, and which lessons were learned?
Yeah, this was, I coined it in 2015, and the University of California asked me to lead faculty from all the 10 campuses and come up with solutions to the climate change problem. And so I was struggling to see how can I communicate to the community of, who are just focusing on carbon dioxide. So I thought, what I explained was that the IPCC and the UN policy community is focusing on bending the emissions curve. What I said was we need to bend the warming curve in addition to bending the emissions curve. So we coined the phrase of bending the curve. And if you see in my background, the bending is gone, all you have is the curve. It's because I've become discouraged whether we are going to be able to bend it. So I cut the bending off.
Cool, we can go on to the next question, and it's by Fredrik. Do you want to say it by yourself, or do you want me to read up from the chat?
Could I just ask what were the lessons learned? Because you also said that 1 million people would be warriors. Which were the lessons learned?
Oh, you're talking about. Can you explain? Can you explain again, please?
Well, I understood that you suggested that 1 million warriors, climate warriors, would go for it. So, yes. What was the experience of that?
Well, that's why we designed this course, Bending the Curve course. And I'm so happy Alistair and Nina and others are teaching it. So we want to use that course to recruit the so-called million warriors. So right now, the course is being taught in addition to Stockholm